Welcome. Today I want to talk about Kubernetes application development with Go, Skaffold and Kustomize. This is sort of a mini workshop, so pace yourself and take your time. This is what I want to cover. First, we write a simple Hello World service in Go. We define environment variables to configure our service. We define a secret environment file to handle passwords. We will mount file system volumes to read files. Learn how to create a Docker container image. Learn how to customize for staging, production, and development environments with Kustomizing for Kubernetes. And finally, do continuous development, continuous integration, continuous delivery with Skaffold. Here is our Hello World service. Starts off by printing the port it listens to. These are variables derived from the environment. So the message is world. The display file is a file path, and a password is supposedly a good password. And this is the main web handler. So it's basically only one handler, and all it says is, it says hello, the greeting, the message. The password is password. Obviously this is sensitive. And finally it displays the file contents. So let's look at display file contents. It opens the file for read, closes the file when this function is done, and copy it to the response writer. Let's run our Hello World service. So I will run the service. It's in command hello main go. You find that the service has started. And I will curl. That's not the right one. I will curl my IP address, port 8080. And there we are. Hello, the message is here, world. That's the password and the contents of the text file. So how do we configure our service? First off, let me talk about git ignore. I want to ignore my vim swap files. I also want to ignore any file with the name secret in it. Well, obviously, those are supposed to be secret and never to be committed into Git. So I have an environment file, which I call local.env for local development environment. And I export the message environment variable as well as a display file environment variables with these values. And I have a local.secret.env. Now this will never be checked into my repository, my Git repository, because it contains a password and it's sensitive. But as you know, this is plain text. And if I source this environment file, I will export the password variable with this value into my environment. So let's try running the hello service with environment variable set. Now I just want to remind you that the message now is world from local environment, and I'm looking at a different sample text, and I have a different password as well. It's called a bad password. So let's source our environment variables. The environment variables are sourced. Let's run our main program again. It is now running, but it's running in a new environment. And let's curl. And you see that the message is different. The password is also different. And the contents is different. H sample text, test data my file. So that is how you configure a service with the environment and secrets. So pause the video, take a break, check that you understand how to configure and run a service locally, and come back and unpause the video when you're ready. Now I want to talk about containerizing our service, how to build a Docker container image. We start with a Dockerfile, and we build and tag our image with a tag of your choice. In this case, I call it my tagged image. This results in a built and tagged Docker image, which I can then run with this command string, docker run, and it will create a container from the image and run it. Let's take a closer look at the Dockerfile. I'm using my Go development image as a builder. So from my Go development image, I call this the builder. This can be any name you want to, but I call it the builder. I copy everything in my project directory to the source folder inside the container, change the work directory to source. I'm using Go modules, so I'll download all the module dependencies. Now, because I will be building my app into root/app, I will need root privilege. I took the precaution of using a regular user for my Go development environment. So I'm now in root. I don't want CGO, I want pure Go. I'll build my application and output it to app. And the application I built is my Hello World service. At this point, my application sits in my builder container, all running, all complete. But now I do a second stage build. I now build from an empty image, it's called scratch. I copy from the builder that artifact, which I call app, into the root. And I copy from the builder test data, because I have a test file called test data, which I read. I expose port 8080, and when this container spins up, it will automatically run the command /app. I tag my container junk because it's a throwaway image. But of course, you want to have a better name for your real production use. This is not the end of the statement. This is a period which stands for build and look for the Docker file in this directory. So build, tag it junk, look for a Docker file in this directory. Oh, let's actually do it, build it. So I'm building it right now. You're seeing it real time, so maybe a bit slow. So it's running the Go compile now. It's running inside the container. Now it's building the stretch container, copying stuff, and it's all built and successfully tagged junk. Without any tag, it's automatically called the tag latest. So let's run the Docker image. But before I run it, let's look at the flags. RM is to remove the container after the run ends. Otherwise, I'll have a lot of containers polluting my file system. -IT or -IT, the -I stands for create an interactive session, and -T stands for allocate a terminal, so I can see what's going on inside the container. -P is to expose any ports to the local machine. Now Docker will allocate a free port and connect it to port 8080. Why 8080? I said it in my Dockerfile. Right, so let's run the container. Actually, it should be in the other window. So I'm going to run the container, and the container, it's not go run now, it's Docker run, has started on port 8080. So how do we test that our container image is working properly? We use the docker ps command to find out which port has been allocated. So let's do that. So it's been up for about 30 seconds, and it's port 49162, which is connected to port 8080. And let's curl the service, test it out. 49162, and I'm calling the root path. And we have our service running again. Notice that it has not been configured because I didn't use any configuration environment variables into my Docker container here. We'll talk about configuration soon. But this is the bare container with the default settings. At this stage, pause the video again, take a break, check that you understand how to containerize an application with Docker. When you're ready, unpause the video, and we now want to talk about Kubernetes. The first step, of course, is to install Kubernetes. There are very many options to install Kubernetes locally. Of course, you can pay to use it in the cloud as well. Google Cloud, AWS have good Kubernetes offering, as does Azure, as does Ali Cloud. But I use micro K8s. K8s, by the way, stands for Kubernetes. That's K followed by 8 characters followed by an S. So if your Kubernetes distribution does not already provide kubectl, I like to call it kubecontrol. Other people call it kubectl. If you don't have kubecontrol, install it from this location and check that you can connect to your Kubernetes cluster. In this case, my Kubernetes cluster is running on my local machine, 192.168.168. When I issue the command get nodes, I find that it has allocated one node, my own machine, and it's ready. This is how Kubernetes looks like, the really high level view, and it's ultra simplified. I've left out a lot of components, but this is the kubecontrol you install. Kubecontrol is a command line application. It uses the Kubernetes API and talks to the Kubernetes controller. Some people think of the Kubernetes controller as the CEO of an organization. I think it's more like the front desk or the routing controller. All it does is it receives requests from the outside world via the API and decides who to route the request to. If it is a request to have something to do with services, which actually is more like a load balancer, it sends it to the service controller. If it's got something to do with running up pods and deployments, it sends the request to the deployment controller. And that's the end of the job of the Kubernetes controller. The deployment controller is a very powerful controller in the Kubernetes organization because many kubelets, each running on a separate node, reports to it. And it is the kubelet that is responsible for creating or destroying pods on a particular node. So our first order of business is to create a Kubernetes service. As I mentioned, a Kubernetes service is not like the service you traditionally think of. It's more like a load balancer that connects the outside world to pods running inside Kubernetes. So the service configures the networking, and the pods run inside Kubernetes. This networking allows the pods to talk to the outside world. For details, check out this link. So the Hello World service should have a Hello service, and I've created this file in a subfolder called Kube for Kubernetes, and that's the contents of the file. Now note the key value pair labels. App is the key and the value is hello. It's under the metadata, so this describes the service, and this has a label app which is equal to hello. We will use this label to locate or find this service later. I'll talk about node pod and the rest in a moment. Yes, sorry about going back and forth. So we can ask Kubernetes to create or update our service using this command, kube control apply -f. The -f stands for read the Kubernetes manifest YAML file and send it to the Kubernetes controller. That controller will now read declarations in the file. If you look at this file again, it declares that the name is hello. It declares that it has this label. It declares that the type is node pod. It declares that the port used is 8080. And it declares that the backend port will be 8080 as well. So it is declarative. And Kubernetes controller will make sure that the Kubernetes environment running inside Kubernetes will match what was requested or declared. So let's do this. Let's run this. So kube control apply, it applies this service file, and it says that the service has been created. And when I ask kube control to tell me what services they are with a label, the -L stands for label, short form, app equals hello, it says the hello service is there. It's a node port type. It has an internal IP of this. It has no external IP. It listens to port 8080, but on the outside world, it listens to port 30195. Now, because Kubernetes is declarative in nature, kube control apply is idempotent, which means it won't make any changes if changes are not needed. Let's try running kube apply again. It says hello service unchanged, and again unchanged. And let's actually look at the service, and nothing has changed. Idempotency, very useful. Now I want to talk about what a node port is. So I've already run kube control get services, and we see the type to be node port. There are different types of Kubernetes services, or think of it as load balancers. You can read more about it here. But a node pod service type means that Kubernetes will allocate a pod on my local machine and connect it to the service inside Kubernetes. So if I look at this again, node pod will allocate this on my local machine and connect it to the service with port 8080. And the service internally, let me go through again, it connects to this port 8080, the service listens to this port, and because it's more like a load balancer, it connects to the back end, and the back end is also listening on port 8080. These two don't have to be the same, but in this case they are the same. So what is a Kubernetes pod? A Kubernetes pod is roughly equivalent to a Docker container, the Docker container that you built in the last exercise. Use this reference link for details. Now, running a pod which is unmanaged directly on Kubernetes is strongly not recommended. Why? If that pod fails, Kubernetes will not restart it. It will just let it fail and said, well, you know what you're doing. You're running a one-off pod. If it fails, it fails. So for educational purposes only, let's create an unmanaged Kubernetes pod. Like everything in Kubernetes, you declare it in a file. So this file is called kube hello pod YAML. And that is the contents of the file. But let me go through some of the things you already know and some of the things you may not know yet. So this pod is named hello, and it has got a label called app, which points to having the value hello. This is the specification for that pod. The first specification item is containers, plural. It can have more than one container. But in this case, it has only one container, and that container has a name hello and uses the image /junk. This container, when it spins up, will have resources allocated to it. At the most, it will use 200 megabytes of memory and 0.7 of a CPU. 700 M means 700 milli CPUs, or 0.7 of a CPU core. This is the maximum it will use. However, when it starts up, it will only request for 1 megabyte of memory and 10 milli CPUs. Here is something which I put in for demonstration purposes. I don't want a termination grace period. So when I ask Kubernetes to terminate this pod, it will terminate it immediately without a grace period, without waiting for the pod to clean up stuff. So 0 seconds. Otherwise, by default, it will wait 30 seconds. And I don't want to wait 30 seconds in my workshop demo. So let's talk about pods, labels, images, and resources. We already have seen the label. The label is called app, and the value is hello. The hello service, this label is important because the hello load balancer service uses this label to find the pod and connect to it. This allows the service to find the back-end pods. Image, as I discussed, already allows Kubernetes to download the image from a Docker registry. Now I called it /junk, but my previous image was called just junk. So let's tag it as tag junk and retag it as /junk and push it to the Docker registry. Let's do that. It's actually talking over the network, so it will take some time. But Go is very small. It's a 6.757 megabyte image. So it's not going to take too long. Meanwhile, I'll check that my recording is working. Yes, it is working. Good. Right, so it has pushed the image to the Docker Hub, and it's available for Kubernetes to use. So now I'll ask Kubernetes to create the pod. Like so. So kube apply the pod manifest. The pod has been created, its name hello. And I ask Kubernetes, find me a pod with a label app equals hello. And there it is, it's running. And it's 14 seconds old. Let's find the node pod again. I don't have such a good memory. So that's the node pod. Let's test it out. Three 0.195, the root path, and it works. Finally, to clean up, I can do this to save a bit of time. I do that. So it says that the pod has been deleted. Kubernetes tells me the pod has been deleted. So if I want to look at the service again, of course it won't work now. I've deleted the pod, but let's do it for good measure. 30195 root path. It times out, connection refuse. Of course, the service is still running. Service is still running. The load balancer is still running. But the back-end pod has gone away, and Kubernetes has done nothing about it because it's an unmanaged pod. Pause the video, take a break, check that you understand how Kubernetes services and pods work. Welcome back. Now I want to talk about Kubernetes deployments. As you know, a pod is unmanaged, a standalone pod is unmanaged. Kubernetes will not recreate or restart the pod if it fails. However, a Kubernetes deployment will recreate pods that fail. Check out this link for details. This is the recommended way to deploy pods into Kubernetes using deployments. So, here is how a deployment is declared in my file kube hello deployment YAML. The labels you now know, app hello. I want to spin up 2 replicas of the pod, and those pods should have the label app hello. This is how the deployment finds those pods. And now I will give it a template, and this is actually a pod template. By the way, this is how a comment is defined. I will give it a pod template, and the pod template will look very familiar because it's actually your pod declaration, exactly your pod declaration, but included or defined in the deployment YAML file. Let's ask Kubernetes to run, to implement this deployment. We'll just do that for the time being. Apply my deployment. It says that the deployment has been created. Get the pods and I find 2 pods running. But notice the pods now have a unique identifier tagged behind them, given a unique suffix. Why are there 2 pods running? Well, I asked for 2 replicas. That's why there are 2 pods running. Good, let's go back to the slides. This command here illustrates the power, shows off the power of Kubernetes. Now I had 2 pods running. Now I want to scale the deployment. I don't have to type in the full word, I just use deploy. You can type in deployment or deployments if you want. But I want to scale the deployment called hello, and the replicas should now be 5. It's been scaled. Okay. Let's get the number of deployments. Let's show how many deployments are available. So get deployments with the name, with the label, sorry, app equals hello. 5 deployments. Let's scale it to 1 replica. Scale it back to 2 replicas. Okay, that was good. I did it fast enough. This shows that Kubernetes is actually trying to do it in real time. So it's supposed to be 2 replicas. At that stage, there's only 1 ready. But if I run the command again, 2 are ready. Excellent, Kubernetes. So the deployment spec works very much like a service selector. I already spoke about that. Notice that we do not reference hello pod anymore. Hello pod can be deleted if we want to. Instead, we use the hello deployment. The hello deployment basic. Why basic? Because we want to talk about configuration maps, just like the local.env configuration file. Here's the reference link, and this is how you define a configuration map. In Kubernetes, you tell it what API version you are using and what it is you are declaring. Here you're declaring a config map. It's got metadata. It has a label app hello, but the name, just to make things less confusing, instead of hello, hello, hello everywhere, I'm calling it hello-config. And the configuration map meets, if you like, the data is this. Looks familiar because it looks exactly like your local.env. The message is now world from Kubernetes, and the display file is test data /my file text. Now remember, when we created the container, we copied test data across, so it's available in the container's local file system inside the container. Let's ask Kubernetes to create this configuration map. The configuration map has been created, and when I ask Kubernetes, please tell me about configuration maps, the name is hello config. It's got 2 pieces of data in there. Nice. Why 2 pieces of data? Here, those are the 2 pieces of data. Now let's talk about secrets like password. Just like your local.secret.env file, it is not encrypted. Kubernetes does provide access restrictions, just like what you do for your local secret env, but it's not encrypted. Here is the reference link. Now I called my secret YAML, I purposely misspelled it. S-E-C-R-T without the E, because if I put in the E, my git ignore will ignore this file and it will never go into my repository. For you, I want to expose this secret. That's fine. Purposely did it for you. So the kind is a secret. The label, you know what it does, but I call it hello secret. It's an opaque secret, means it's an envelope which you can't see through, but inside that envelope which you can't see through contains string data. Normally when you use data, this is base 64 encoded. But if I use string data, it's in clear text. So the password is a Q7 for 7 of 9. That's where all the Star Trek Kubernetes stuff comes from. Password. So let's ask Kubernetes to install this secret. The secret has been created. When I ask Kubernetes, give me a secret with a label app equals hello, there we have it. One piece of data, 6 seconds old because I just created it. We will now create a deployment with config maps and secrets. So this is a new deployment file called deployment-env. And here are the things that have changed. The image stays the same, but now it has got the environment which is retrieved from a config map reference called hello config and a secret reference called hello secret. So let's delete any old deployments just to make sure. The deployment has been deleted. There is no deployment now. I ask Kubernetes, find me a deployment with this label. None found. Good. Let's deploy our new deployment file, the env file. That deployment has been created with the env, with the environment. Ask Kubernetes for deployment detected. It's up and running, all 2 instances of it. Let's test the service. Notice that the service doesn't change. I ran this command so that I don't have to remember. 30195 root. Now when I run this, the message should be different and the password should be different as well. Yes. The message is different. Password is different. Excellent. I haven't changed the contents of the file yet. That's what we're going to talk about next. But before that, take a break, pause the video, check that you understand how config maps and secrets work together with deployments. Welcome back. Now let's talk about Kubernetes volumes and volume mounts. A Kubernetes volume is a piece of storage, and a volume mount is where it is mounted inside the Kubernetes pod. That's the reference link. So volume and volume mounts are declared within a pod template, typically within a deployment. So we have a new deployment file now called deployment-volume, VOL. This you have seen before, but this volume mount is new. This volume mount, I name it data-vol, data volume. And this data volume will be mounted inside my Kubernetes pod under the path /test data. And here is where I actually define my volume. This volume is called data volume. These two must match. That's how they link up. And I'm using a volume of type host path. Host path means take my host, look at a path in my host, which in this case is 192.168.1.68, my local machine, and expose it to Kubernetes. So as you can imagine, my home directory will not be available in a production Kubernetes cluster. So host path volumes are very useful for demonstration purposes, but they will not work in production. So in production, we will use equivalent of a hard disk on my local machine, but available in the cloud. And these are called AWS Elastic Block Store, or GCE Persistent Disk Volumes, or Azure and Ali Cloud have similar offerings. Again, we want to make sure that our old deployments are gone. Our old deployments are gone. No resources found. Ask Kubernetes to install our new deployment. The new deployment is installed, not quite ready yet. Now it's ready. And let's get the service. Now when I run this 30195 root path, you will find that the file system read will now read with different contents. Home Xilian, no longer the previous one. So the contents now have changed. That is how you define different volumes. Here is the development process summarized. 5 major steps. Of course, we must write our service code. I wrote it in Go. You can write it in TypeScript, Node.js, Python, any language you are familiar with, because you can Dockerize your service, no matter what language it has been written in, into a Docker image and push it to an image registry. I use Docker Hub. You can use an AWS image registry or Google Cloud registry, up to you. We first create a Kubernetes service, which is like a load balancer. It connects the outside world to Kubernetes pods. But we don't use pods directly, we launch pods via deployments. We create and apply config maps or secrets to configure our deployment, which references all these things. We just talked about these 3 things, and we just talked about volumes and volumeMounts. Pause the video, take a break, congratulate yourself. You have covered Kubernetes 101. Make sure you understand it. Welcome back. Here's a reality check. The real world is not that simple. Here is what you need to be production ready. Docker images shouldn't be tagged with latest and shouldn't be called Xilian junk. It should be called something like this, version 1.03 or a git commit tag. Our deployment names should be called hello staging or hello prod instead of just hello. It should reflect the different environments. Now, as you imagine, going through all those 5 major steps is a pain. And we need to have a systematic, sustainable, automated, error-free way of customizing our maps, our secrets, volumes, to accommodate all the different environments, staging, production. And this is a non-trivial task. To address task 1, I'll use a tool called Skaffold. I'll cover this last, but first I want to talk about Kustomize, which addresses concerns 2 and 3. So as I said, I will talk about Skaffold last, but I want to manually tag our image for now. So let me change hello, our service, and call it version 0.1.1. And I want to change hello to greetings. So let's do that now. Oh, I've got a file open. Save it. If I reload my presentation, it says greetings now. Now let's build and tag and push our new image to Docker Hub, the Docker registry. This will take some time. It's rebuilding the new version 0.1.1. It's running the Go compile. It's done. It's pushed it. Not yet. I'm pushing it now. Pushed it to the Docker registry. Done. So now we have a Syrian junk version 0.1.1. Now I want to update my hello deployment volume to version 0.1.1. Let's update it, okay? That's Syrian junk version 0.1.1. Save it. If I reload my presentation, it says 0.1.1. Let's update. Now previously it said hello, now it will say greetings. Apply, configured, get the service, 30195 root path, greetings. So now we have pulled in a new image with a new version of our service. How do we customize for different environments, staging, production, etc.? Well, Kustomize version 2.03 is free. It's built into kubectl, kubectl, but you must use kubectl version 1.14 and above. Let me prove it to you. I'm using the command kubectl help, kubectl here, and say help customize. Hey, it's got Kustomize built in. Well done. I'm using kubectl version 1.17. There we are. I've also downloaded and put Kustomize. It's available as a standalone binary. Why? Well, this command will tell you why. It's the latest and greatest. I'm using Kustomize version 3.91. Kubectl has standardized and frozen on version 2.03. So I want the latest and greatest features, of course. How do you begin to use Kustomize? We begin by creating a base folder. It holds the starting point of our customizations. So let's go into our kube configuration folder, create a new folder called directory or folder called base, and copy all our YAML files into base. Inside base, I create a file called kustomization.yaml. And this is how it looks like. API version. It's a customization. Here is where it's different. This command, this declaration says, anytime you see a label called app, I want you to overwrite it and call it hello. So whatever app was in these manifests, these files, it will be overwritten and it will now be called app hello. In this case, I overwrote it with the same value. And these are the resources that are under customization's control. The resources are all these manifest files. Here is how we run customization. I will run it with kube control, just in case you haven't downloaded customization binary yet, customized binary. I will run it and make it compatible with version 2.03. Note that I use kube control apply, but not -f now. It's -k or -k. Apply kube base. The configMap has been unchanged. The secret has been updated. The service has been unchanged. The deployment's unchanged. The pods are running. And it's 30195. It still runs. Good. Now let's create a new environment called staging. I want staging to use the older version, the one without the 0.11 tag. And the name should be called hello staging and not just hello. So let's make a folder to hold our staging customizations. So I'll make the folder inside the kube folder, but I create an overlays staging folder. I've already created it, so I won't run it. This is the customization file inside overlay staging. This declaration says all names will now be suffixed with -staging. All labels called app will now be rewritten as hello staging. Now we've used customization version 3 and above. Basis, this declaration basis has been deprecated and is replaced by using resources instead. But because I'm using kube control and it's version 2.03, I'm using basis. What basis does is it refers to the base customization, the starting point. And it is 2 directories above. Right. Now that customization file continues. That file is quite big. It's got a configMap generator in there as well. This is how we overwrite the message in hello config. Now it's still called hello config, not hello config staging, because the name suffix here will overwrite it and call it hello config staging. If I put hello config staging here, it will be called hello config staging, which is not what I want. And I'm overwriting by merging. Now I didn't change the display file. It will just take whatever's that is newly defined here and merge it with hello config. So I'm going to say staging world from customize staging. Oh, I made a mistake here, but never mind. I actually want to merge a new secret, and the secret will have a new password. No worries, I'll fix it in a later presentation. I'll show you the file. It's cube, overlays, staging, customization. So that's the config map you saw, and this is the secrets generator. It's called hello secret, and the password is now a staging password. We also want to patch our deployment image with a different volume. Well, not with a different volume, in this case with a different image. So let's patch the image, and staging patches is actually quite long because it has to uniquely identify what it has to patch. And what are we patching? We are patching a deployment, which is called hello. What are we patching? We are patching the spec template specification container named hello, and the image should now be just called Xiuyinzhang, not Xiuyinzhang version 0.1.1. Let's apply and test our staging customization. Now we have created a new config map called hello config staging, new secret, new service, new deployment. And the service hello staging now has a new node pod, not the old one anymore. And the pods have new names with unique IDs. 32049 root path. The message should be different, the password should be different. Yes. Yes. And yes. Why? Version 0.1.1 says greetings. The old version said hello. So we show how we can manage images and patches with Kustomize. Let's tear down our two different environments. Delete, not -f, -k. I'm using Kustomize to delete everything in base. So hello config, gone. Deployment, gone. Do the same thing for staging. That's how fast it took. Now it's all deleted. Take a break, pause the video, check that you have understood how to customize for different environments. Welcome back. I now want to talk about continuous integration and continuous deployment with a tool I use called Skaffold. Now, Skaffold is not only a CI/CD tool, it's also a continuous development tool. As usual, we need a YAML file to declare to Skaffold what we want it to do. So Skaffold YAML, the API is now version 2, quite mature. It's a configuration. We tell Skaffold that our build artifacts is only one. Our image is called Xiuyinzhang. And the Dockerfile context, the Dockerfile, is located in the root folder, the project root folder, right here, dot. And Skaffold YAML is in the project root as well. We tell Skaffold how we want to deploy. We want to deploy using Kustomize, and Kustomize, the base configuration is in cube base. Now, because we say we want to deploy using Kustomize, we now need to download the standalone binary, and this must be inside your path so it can find the binary. Let's do Skaffold run. Now remember, we've destroyed our previous infrastructure, so we're going to do it from scratch now. Yeah, we destroyed our previous infrastructure. Scaffold run is creating our new Go Docker container, our hello service Docker container. It has tagged it with a unique tag. It's pushing it to the registry. It's doing all this on its own because we told it in Scaffold YAML. It has created the configuration, the secret, the service, the deployment. The deployment itself is ready. We now have a new node port, 30316. The pods are running, 30316. Get the root path. It's working. We use the latest version of our Go Hello World service. Let's change our Go Hello World service and do it all over again. Here's a new version called Salutations. Let's save it. Run it all over again. So it's rebuilding my Go Hello World service right now in real time. Tagged it with a different tag. Now if I committed my repository, you will tag it with a git commit, but here it tags it with a temporary tag, and this is what is pushed to Docker registry. It's very unique. That's the SHA-256 of the Git. Everything is up and running. 30316 root path. Salutations. Wonderful. I call this continuous development. Now, this is the short form of what I actually do for my development environment. Here I'm actually pushing to the real Docker hub, and it's going over the network, and there's network latency, so it's a bit slow. In my real environment, I create a local Docker registry. Not Docker hub, but a local registry. Because it's local, running on my machine, it is super fast. So I can actually do it in real time. When I run scaffold run, that command will tear down and redeploy the infrastructure. The previous infrastructure will be destroyed and new infrastructure will be recreated and redeployed. I find this a waste of time. I want Scaffold to only recreate infrastructure that has changed. Don't destroy and recreate infrastructure that has not changed. You can do this with Scaffold, but it's quite cumbersome. You have to type Scaffold label, give it a run ID. In this case, my run ID is just my name, Surian, and then type Scaffold run or Scaffold delete. So what I've done is created a small script called iscaffold.sh, shell script. It does essentially what I asked it to do. I gave it a run ID. And to run, instead of typing scaffold run, I now type iscaffold.shell run. Let's do that. Let's deploy it to staging with iscaffold. You won't see any difference because it has a different run ID, but I'll show you that it works. It's now iscaffold. It's going through the whole thing again. I have to do this the first time. But when I run iScaffold again with nothing changed, you see the port has changed because I've torn down the service. 30898 root path. It runs, of course. If I run iScaffold again to staging, it's super fast now. Not change, not change, not change. It's ready. And if I curl it again, still works. Tear down everything in the base environment as well as in the staging environment. I just want to show you how quickly that is done. Delete everything in the base environment, so hello config, hello secret, all gone. Kill, remove the staging environment, done. We have now come to the end. If you want the code to this presentation itself, as well as all the code samples and the declaration files, it's available on my GitHub repository here. I am Siu Yin and I work for Zendit.